Hello friends, in previous video we are discussed only two conditions. One is f of t is a constant and another one is an exponential function. And in this video we have to solve time domain function is a sine of at and we have to convert in frequency domain, and what will we get? Find Laplace transform of sine of at, that is Laplace transform of sine of at is equal to a over a square plus a square. We have to prove this condition of Laplace transform of trigonometric function sin at. So with the help of the definition we can solve. So solution, already we know that the definition of Laplace transform, by definition of Laplace transform, Laplace transform of f of t is equal to integration minus st f of t and dt, and this is the definition of the Laplace transform. And here time domain function is given, f of t is sine of at. So I take f of t is a sine of at. Just we have to substitute this f of t in a condition of Laplace transform and we have to apply the integration, and definitely we will get the solution. So therefore Laplace transform of sine of at is equal to integration 0 to infinity minus st, and f of t is given sine of at and dt. So now look at this condition. So exponential function and trigonometric functions both are the variable, and we know that the properties of integration, when the variables are in product we have to apply the by parts method, but if you apply the by parts method to this one and it gives some difficulties. So already proved or derived the formula for this condition. Those are the properties of integration. I will take note here, or remember, when integration of exponential function with a sine or cos, already these are the derived formula at and sine of bt. So this one is sine of e to the power at divided by a square plus b square and a into sine of bt minus b into cos of bt. Just we have to compare with this condition and definitely we will get the solution. So here limit value is given, and after that we have to apply the limits which implies Laplace transform of sin at is equal to integration 0 to infinity e to the power st sine of at into dt. So now we have to compare this condition with a standard formula. So comparison. Now look at this one. Here minus s is there, but in a condition a is there. So it means our a is a minus s, just we have to take here. So e to the power minus a is a minus s minus st, and a is a s square, it means minus of minus is positive. So a square plus a square, b is taken here, compare with this. So b is here in condition, but in our problem a is there. So b is equal to, a is equal to b and a is equal to minus s. So minus s of sin 80 and b is a of cos of 80, and apply the limit value 0 to infinity. First we have to take upper limit, e to the power minus s, and t is our variable, and that is infinity, and divided by a square plus a square minus of s into sin a into infinity and minus a of cos of a into infinity and minus. So upper limit we have to apply it, and now apply the lower limit value. So e to the power minus s of s into 0, and here a square plus a square minus s into sin of a into 0 and minus a into cos of a into 0. So now we have to solve. Now look at this condition, exponential function of minus infinity, so it gives 1 over e to the power infinity. It means, so this condition become 0, it means whole thing is 0, and next minus of e to the power minus s into 0, it means 0, the value of e to the power 0 is 1, so 1 over this, the value is 1, and now minus s, and sin of 0 is, sin of 0 value is 0, it means minus s of into 0 and minus a into cos of a0, it means cos 0 value is 1, so a into 1, and now so this minus and this one is 0, this is a 0, minus of minus plus, and a is remaining, numerator a and denominator is a square. So this is the solution of time domain function of sin of 80, and that is a over a square plus a square. Laplace transform of sin of 80 is nothing but a over a square plus a square, and this is the solution of time domain function of sin 80. Find Laplace transform of cos of 80, and that is Laplace transform of cos of 80 is equal to, your numerator is, we get s and a square plus a square. So try yourself. So very simple, and we have to change here the integration of e to the power 80 and cos of bt, and we will get, with help of that condition we can prove this one. I will give the property of the integration, that is when integration of e to the power 80 and cos of bt, and we get we get e to the power 80 and a square plus b square and cos of a into cos of bt plus b into sin of bt. So apply this condition for the cos of 80 and we get the solution of s over a square plus s. Now we discuss another two functions. Those are sine of hyperbolic 80 and cos of hyperbolic of 80. So we solve or we find the sine of hyperbolic. Find the Laplace transform of cos of hyperbolic 80, and that is Laplace transform of cos of hyperbolic 80 is equal to, so in numerator s and denominator a square minus a square. We are going to solve cos of hyperbolic 80. So with the help of the definition we can solve. Solution: by definition of Laplace transform, already we know that Laplace transform of function time domain f of t is equal to integration 0 to infinity e to the power minus st f of t and dt, where f of t is nothing but cos of hyperbolic 80, and this cos of hyperbolic 80 can be converted in exponential form e to the power 80 plus e to the power minus 80 over 2. So in the definition of Laplace transform we can substitute cos of hyperbolic 80, and after that we have to simplify with the help of the definition also, or we can solve this one directly. We have to apply the Laplace to this condition, and already we seen one of the condition when Laplace transform of e to the power 80 is there, then we can write 1 over s minus a. That is also one of the condition for the solving. So we will solve this one. Apply here, therefore apply here Laplace transform of f of t, and that is Laplace transform of cos of hyperbolic 80, and apply the Laplace transform of this condition. I will take 1 over 2 is common, and Laplace transform of e to the power 80 plus e to the power minus 80. So which implies 1 over 2 Laplace transform of, just simplify it, 80 and plus Laplace transform of, we have to apply the linearity property, Laplace transform of this one and Laplace transform of exponential of minus 80. So Laplace transform of minus 80, and here 1 over 2, and now look at the Laplace transform of e to the power 80, and we already seen and we know that the condition of that one Laplace transform of, because Laplace transform of e to the power 80 is, we already derived this one 1 over s minus a. So with the help of this condition we can write directly, and this one is 1 over s minus a, and this plus when is negative, and definitely we get in positive in frequency domain. So 1 over s plus c. So simplify it, take LCM, 1 over 2 s plus a plus s minus a, and which is looking like a minus b into a plus b, that is the formula, a square minus a square, and here positive s is there, 2 times s, and a minus a and plus a get cancelled, and we get 1 over 2 times s, a square minus square, and 2 get cancelled, and this is nothing but the solution of cos of hyperbolic. So look at this here and we get the proof, and try yourself when sine of hyperbolic 80 sine of hyperbolic 80, and that is Laplace transform of hyperbolic of 80 can be written a over a square minus a square, and definitely you get this solution. And here sine hyperbolic 80 is nothing but just we get here minus, and apply this formula for the function sine hyperbolic 80, and we get the solution. Just same procedure, and try yourself. In next video we will see some other condition of Laplace transform or signals. Thank you.